This is Organic Chemistry Video 1. In this video, we are going to talk about what organic chemistry is, as well as an overview of what hydrocarbons are and how to identify the formula of a hydrocarbon. I need you to go get your reference table and open up the table P and Q and be ready to write on the table and go. Here we go. Organic chemistry is all about carbon. So you need to know that anytime a compound contains carbon, we're talking about the properties, being able to identify it, or anything about carbon, we're talking about some type of organic chemistry. Carbon is unique because it has the ability to bond to itself in long chains and rings. So whenever you see a long molecule containing many carbons and hydrogens, we can call that an organic molecule. Compounds that do not contain carbon are called inorganic. So we have a new vocab word, hydrocarbons. Those are organic molecules because they contain carbon. They're molecules that contain carbon and hydrogen only. So they do not have any other group, carbon, hydrogen only. So glucose is C6H12O6 would not be a hydrocarbon because it also contains oxygen. We're looking for things that contain carbon and hydrogen only. Here are some real life examples. You don't have to copy these down, but methane, it's natural gas. It's used to heat your home. Look at the formula, CH4, carbon and hydrogen only. Propane, C3H8, it's used as a heating oil, carbon and hydrogen only. We also have many compounds that are in gasoline and petroleum oil made up of larger groups like 5 to 12 carbon atoms. Those are hydrocarbons because they're just carbon and hydrogen, but they very large. We also have even larger hydrocarbons containing chains of 20 or more, and those are the things that are typically found in candles and wax. In this unit, we're going to be looking at different types of formulas. So I just want you to understand that they have specific names for the formula we look at. When we write a molecular formula like C3H8, we're just writing the symbols with the total amount of atoms per element. Structural formula is showing me the arrangement of how the atoms would be arranged if we were to build them out, let's say with a model kit. And the condensed structure is showing me the atom with how many you have of each at each site. So for example, if we look at the structural formula above, you have a carbon all the way on the end, and there are 3 hydrogens attached to it. And then there's a carbon and how many hydrogens are attached to. And then all the way to the right, you have a carbon and 3 hydrogens. So it's showing you kind of the layout. We'll do a little bit more practice with that in class. Today, what we want to understand is how do you name a hydrocarbon? So lucky for us, we have a reference table, table P, that will go through the prefixes of how we're going to name them. You should be familiar with a lot of prefixes. They're kind of things that we've used since you're young, like hex means 6, hept means 7, oct is 8, pent is 5. But is 4. Yes, that's but, not but. When you say but, it doesn't sound good, so we're not going to say that. Prop is 3, eth is 2, and meth, everybody gets all excited about meth, like we're actually going to learn about that? No. But meth means 1 carbon. So those are the prefixes that we need to know for the purpose of Regents chemistry. Then there are suffixes. So the suffix to any compound is going to be ane, ene, or yne. And we're going to go through table Q now. We'll show you when to use each one. So first, let's start with our alkanes. There are 3 different types of hydrocarbons that we have to know. Alkanes, alkenes, and alkynes. They sound all kind of similar, but ane is ane, ene is ene, and yne is actually pronounced eine. In this table, they give you a general formula for what the compounds will look like, and then they're giving you an example, a name, and a picture. First observation tell you that, okay, an alkane has a single bond between the carbons. An alkene, the ene, has a double bond. Double bond, remember, is 4 electrons being shared. And yne is a triple bond, so 6 electrons are being shared there. In the general formula, when you figure out how many carbon atoms something has, which you're going to use table P, our prefixes, to do, when you figure out the number of carbon atoms, you're going to plug that in. Whatever value you get for n, you're going to use the same value for n in the second part of the equation where it says here, like let's say 2n plus 2. The n in the second part of the equation is the same as the n here. So let's go through some examples in a minute. First, we have to understand that alkanes are going to be referred to as saturated. Saturated begins with an S, so does single bonds. So that's lucky and nice for us to remember that when you are saturated, you have all single bonds. So if you look at the alkane group, the example they give you here is ethane. Look at ethane's bonds coming out of that carbon, all single bonds, right? So both carbon atoms, single bonds. So saturated, new vocab word, means single bonds. All alkanes have this general formula, CnH2n plus 2. Again, you don't have to memorize it. It's right here, CnH2n plus 2. We're not lying. And they're all going to end in ane. So regardless of what the prefix name is, like meth, eth, pro, but, whatever, from table P, when you have an alkane, meaning everything is all single bonded, your ending will be ane. So let's look at some examples of how you name an alkane. The very first alkane in the series is methane. What does meth mean? Meth means one carbon. Okay, what does ane mean? Ane means it's saturated. Ane means it's an alkane. It also means it obeys this general formula, CnH2n plus 2. Where did that come from? That came from our table, CnH2n plus 2. So let's say I'm talking about methane. Meth, we said, was one carbon, so N is going to be 1. Now, if you look at the hydrogens, you have to figure out, well, how many hydrogens does methane have? It would have 2 times N, so 2 times 1, 2, plus 2 equals 4. So methane is going to have 1 carbon and 4 hydrogens. So that's where they get the C1H4. And we don't write 1, so it's just CH4. Let's look at ethane. Eth on table P means 2 carbons. So eth, you come here, you look, eth is 2 carbons. Now you got to figure out how many hydrogens based on the general formula. If carbon is 2, that means N is 2. Then for your hydrogens, you're going to do 2 times 2 is 4, plus 2 is 6. So ethane is going to have 2 carbons, 6 hydrogens. So we already talked about the fact that carbon has 4 valence electrons. Here's a structural formula of methane for what methane would look like, 1 carbon, 4 hydrogens. What I'd like you to do is draw methane in your notes, draw C2H6 and C4H10 in our notes, and I want to see if we can get them correct. We'll go over what the picture should look like tomorrow. Make sure that you draw them all with single bonds because these are all alkanes. 2 more for our alkane series. We have propane and butane, just to make sure that you do understand how this whole system works. Again, we're using the general equation on table Q. So Cn, that means we have 3 carbons because the prefix prop means 3. And then you have your 2n plus 2. So 2 times 3 is 6 plus 2 is 8. That's how you get C3H8. Butane, you would use but from table P. But means that you should have 4 carbons, and then you use your general formula to figure out that 4 times 2 is 8 plus 2 is 10. So the amount of hydrogens you're going to have will be 10. So this is what we call a homologous series. Each member differs from the previous member by by 1 carbon and 2 hydrogens. So if we look at the first one, the series is CH4, methane. Ethane is C2H6, so it changes from methane by 2 carbons, 1 carbon because there's really 1 here, and 2 hydrogens. Ethane, and then let's look at propane. Propane differs from ethane by 1 carbon, 2 to 3 will be 1 carbon and 2 hydrogens. Since each member of the series changes by 1 carbon and 2 hydrogens, it's changing by a constant amount. We call this a homologous series. So table Q is all about homologous series because each of the series, alkanes, alkenes, and alkynes, are going to differ from each other by carbon and hydrogens that are going to change in a constant amount. Next in the chart, you have alkenes. Those are not single bonds, so they will not be saturated. We'll call them unsaturated. They obey the general formula CnH2n. So remember that double bond has the 4 electrons. Here are some examples. They're just doubling. Cn, so if n is 2, H is 2 times 2 or 4. They're always going to just double. C3H6, C4H8, C5H10. So alkenes are pretty easy to figure out. And last we have alkynes. Those have the triple bond, also unsaturated because they're not single bonds. Their general formula is CnH2n minus 2. And then some examples would be propyne. So propyne, prop means 3 carbons, so N is 3. H would be 2 times 3 is 6, minus 2 gives you 4. Butane, the prefix but means 4. Yne means 2n minus 2, so 4 times 2 is 8, minus 2 gives you 6. So in summary, alkanes have single bonds and are saturated. Alkenes have double bonds and are unsaturated. Alkynes have triple bonds and are also unsaturated. And we'll stop there.